Hello, welcome. So to actually show us what these alpha particles and beta particles look like, I'm going to use these. So this is an alpha particle. It's actually helium. You can see this is 4 and 2. So this is how you represent alpha particle with this sign alpha, having a mass number of 4 and atomic number of 2. For beta particle is electron. Alpha particle is actually synonymous to helium. This is the sign. Beta particle is synonymous to electron. So this is how you represent it. Either you use the electron itself, which has mass number 0, electron is -1 charge, or use the beta sign, 0 and -1. Whereas gamma is actually no charge, no number. It's very light. You can see 0, 0, or like this. So these are these three emissions: alpha, beta, or gamma. You can also have neutron, which is mass number 1 and atomic number 0, like this, or proton, which is actually a single hydrogen 1 1, or positron, which is 0 mass number and atomic number +1. So these are the rays that could be emitted in radiation. As a point of correction, X-ray is not radioactive. It's actually through heat, thermionic emission. But for radioactivity, we have these the major things. The major emissions are alpha, beta, and gamma. But you can also have these other smaller particles. So now we look at half-life. Now, when you're talking about half-life, you're talking about this formula that N, that's the number of atoms remaining, is actually equal to the initial number of atoms times 1/2 to power n, which is the half-life, where n is the remaining amount. This is remaining amount. NO is the initial amount. N is the number of half-lives that have passed, this small n. So this n is actually equal to T over big T, where T is the amount of time passed and big T is the half-life. So you can use it to do a calculation like this. So take note of this formula. N is equal to initial number of atoms times 1/2 n, where n is T, which is time passed over half-life. So you can actually put T over big T here. So that is the formula for half-life. I'm going to close this down, and then I'm gonna delete this and delete this and open this up very well. So these are those emissions. This is the alpha particle, which I told you is synonymous to helium, with mass number of 2 and atomic number of with mass number of 4 and atomic number of 2. The charge change in the atomic number is -2, change in mass number -4, change in neutron -2. For beta, it's the same thing as electron, and it has no mass number and has charge of negative. Gamma does not have neither charge or mass, that's why it's very light. So you can also have the positron and the electron capture. So those are the major things that you need to know in radioactivity. So I'm gonna do Ctrl Z and bring back all the other things that I deleted. Please, if you like this video, hit the subscribe button. If you want to support us in any way, check the description part of this video. Like and share this video. Thank you. God bless you.